NASA's long-standing exploration of Mars has consistently fascinated people around the world, achieving remarkable milestones that have significantly expanded our comprehension of the red planet. Among the most pivotal accomplishments in this journey was the successful touchdown of the Perseverance rover in February 2021. This highly advanced robotic vehicle has delivered some of the most detailed images of Mars to date, offering stunning 4K visuals that showcase the planet's ancient and rugged surface features. Perseverance follows in the footsteps of earlier missions, particularly the Curiosity rover, by continuing to challenge the limits of what is technologically and scientifically possible in planetary exploration. Both rovers have made fundamental contributions to our understanding of Mars' geological evolution, climate history, and potential to support life. Perseverance was deployed to Jezero Crater, a location chosen with great care by scientists due to its geological promise. This area is believed to have once been a vast lake over 3.2 billion years ago, making it an ideal spot for searching for signs of ancient microbial life. Outfitted with a suite of cutting-edge cameras and scientific tools, Perseverance has been collecting valuable data from its surroundings. These visuals and measurements do more than captivate the eye. They provide essential information for studying the planet's former habitability and evaluating its suitability for future human missions. NASA's extensive commitment to Mars exploration, involving an investment of billions of dollars, is rooted in the profound quest to answer one of humanity's oldest questions. Are we alone in the universe? This pursuit has propelled the agency to launch increasingly sophisticated robotic missions. Among the earlier breakthroughs were the twin rovers Spirit and Opportunity, launched in 2003. These machines were instrumental in confirming that water once flowed across the Martian landscape. Through the discovery of specific minerals formed in the presence of water, they demonstrated that Mars may have once offered conditions suitable for life. Opportunity, in particular, exceeded expectations, continuing its mission for nearly 15 years and delivering thousands of images and valuable scientific insights that continue to influence planetary research. In 2012, NASA took another leap forward with the landing of the Curiosity rover in Gale Crater as part of the Mars Science Laboratory mission. The site was selected for its rich geological features and clear indicators of past water activity. Mount Sharp, the crater's central peak, rising 5.5 kilometers above the floor, presents layered rock formations that act as a geological archive of Mars' environmental history. Curiosity's mission focused on determining whether Mars ever had the necessary ingredients to support microbial life. It was equipped with tools capable of analyzing rock, soil, and atmospheric composition. One of its standout instruments, ChemCam, used a laser to vaporize tiny portions of rock, allowing scientists to study the resulting plasma and determine its elemental content. These analyses revealed critical information about Mars' volcanic activity, history with water, and interactions with its atmosphere. Curiosity also contributed to understanding how Mars's climate has shifted over billions of years, from a once warm and wet environment to the cold, barren world we observe today. Key data from Curiosity's radiation sensors helped scientists assess the viability of future human missions by measuring exposure to cosmic and solar radiation. In 2013, the rover discovered an ancient streambed, solid evidence that liquid water once flowed through Gale Crater. The presence of clay minerals further supported the theory that Mars experienced a wetter and potentially habitable past. Seasonal methane fluctuations detected by the rover raised intriguing questions about whether subsurface biological or geological activity might still be ongoing. Building on Curiosity's success, Perseverance launched in 2020 with an even more focused objective: the search for signs of ancient life. One of its central goals is to collect and store rock and soil samples for eventual return to Earth, a major component of the Mars Sample Return Initiative in collaboration with the European Space Agency. This effort will enable scientists to study Martian materials in Earth-based laboratories, which offer far greater analytical capabilities than instruments on board the rover. On March 4, 2021, Perseverance conducted its first test drive, leaving tracks in Jezero crater and marking the start of a groundbreaking mission. Since then, it has made numerous discoveries, including unusual rock features referred to as leopard spots, which may provide new information about Mars' ancient environment. The mission has also resonated deeply with the public. Campaigns like Send Your Name to Mars allowed over 10 million people to symbolically join the mission, while a commemorative plaque honored healthcare workers who served during the COVID-19 pandemic. Additionally, a hidden binary coded message on the rover's parachute spelled out "Dare Mighty Things," reflecting the spirit of exploration. Perseverance has captured some of the most striking visuals ever taken on Mars. One iconic image, known as the Octavia E. Butler landing photo, shows the exact moment of touchdown, with smoke rising from the descent stage. Panoramic images, such as those taken on Sol 14, reveal Mars's expansive and rugged terrain in incredible detail. The rover's rear hazard avoidance camera not only assists with navigation, but also offers compelling views of the Martian surface. A notable image taken on Sol 213 depicts the discarded parachute and backshell about 2 kilometers away, serving as a dramatic reminder of the mission's complex entry sequence. Another historic milestone achieved during the Perseverance mission was the deployment of the Ingenuity helicopter, which in April 2021 became the first powered aircraft to fly on another planet. Its inaugural flight occurred in a region aptly named Wright Brothers Field. Since then, Ingenuity has far exceeded its initial 5-flight plan, completing numerous missions and capturing aerial video and even audio of the Martian environment. During its 11th flight in August 2021, the helicopter photographed Perseverance from above, providing a rare perspective of the rover in action. Together, Perseverance and Ingenuity have helped researchers map Martian terrain more accurately and identify areas of scientific interest. Additional breathtaking images, such as those from the Van Zyl Overlook, offer wide views of Mars's undulating hills and layered geology. Meanwhile, overhead visuals from the Mars Reconnaissance Orbiter place Perseverance in its broader context, offering valuable geographical data. Reciprocal images of Perseverance and Ingenuity observing each other give a human dimension to these robotic pioneers, highlighting their collaborative role in exploration. As both Perseverance and Ingenuity continue their missions, they are paving the way for eventual human exploration of Mars. The data they collect is essential for understanding the hazards of Martian conditions and for developing strategies to support long-term human activity on the planet. From evidence of ancient riverbeds and sediment layers to the detection of fluctuating atmospheric gases, their findings present tantalizing possibilities about the planet's potential to have supported life, either in the past or possibly even today. NASA's efforts to explore Mars stand as one of the most extraordinary accomplishments in scientific and technological history. These missions have revealed many of the Red Planet's secrets and brought us closer to answering whether life exists beyond Earth. The continued success of Perseverance signals a new chapter in planetary research, one that redefines how we view our place in the universe and inspires new generations to look toward the stars with curiosity and determination. Extending the legacy of these missions, the broader impact of NASA's Mars program reaches well beyond science alone. It speaks to human ingenuity, philosophical inquiry, and the collaborative spirit of discovery. Perseverance, in particular, represents the beginning of a new phase in which robotic and human efforts will work together to explore neighboring worlds. Its mission builds upon the foundational work of previous rovers like Spirit and Opportunity, which were only expected to operate for about 90 days. Remarkably, Opportunity lasted nearly 15 years, covering over 45 kilometers and sending back vital data that included sedimentary rocks and hematite formations known as blueberries, evidence of water-related processes. Spirit, although eventually immobilized in soft soil, also made critical findings, such as evidence of past hydrothermal activity beneath the Martian surface. These earlier missions were crucial in confirming that Mars once had the environmental conditions necessary for water to exist, an essential ingredient for life. Curiosity's arrival in 2012 brought an even more sophisticated toolkit for studying the planet's climate and surface. It uncovered elements vital to life, including carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur in the Martian soil. Its examination of Mount Sharp's rock layers provided insight into environmental changes spanning billions of years, suggesting Mars was once a habitable world with liquid water. One of Curiosity's greatest scientific contributions came through its atmospheric studies. The rover helped confirm that the loss of Mars' magnetic field billions of years ago exposed its atmosphere to solar wind, gradually transforming the planet from warm and wet to cold and dry.